Walk into a giant sequoia grove for the first time, and you feel it immediately. This overwhelming sense of age and permanence, like nothing on Earth could ever threaten these trees. And for most of human history, that was basically true. Some of these trees have been alive for over 3,000 years. They've outlasted droughts, floods, the Little Ice Age, and centuries of lightning strikes. So, when rangers started deliberately setting fires beneath them, people thought they had lost their minds. Here's what this video is actually about. For most of the 20th century, the official policy across American forests was to put out every single fire as fast as possible. And that policy, which seemed completely logical at the time, quietly pushed the giant sequoias toward a slow-motion extinction that almost nobody noticed. Then, in 1968, a small group of researchers and park managers did something that felt radical. They started burning the forests on purpose. And the story of how that happened and what they found when they did is one of the most quietly remarkable reversals in the history of conservation science. There's one thing at the center of all of this that I want you to hold on to as we go through this, because it changes how you understand everything else. The giant sequoias were not just surviving alongside fire for thousands of years. They were built for it, down to the biology of their cones. And when fire was taken away, something started going wrong that took decades for anyone to even notice. We'll get to exactly what that was. But first, let's start with what the forests actually looked like before any of this became a problem, because that picture is genuinely surprising. When the trapper Joseph Walker crossed the Sierra Nevada in 1832, he was among the first Euro-Americans to travel through those forests. His party moved through on horseback without much difficulty, weaving between enormous trees with open ground underneath them and plenty of light reaching the forest floor. He described finding trees of the redwood species with trunks so wide it was almost unbelievable. And that openness, that sense of a forest you could actually ride through, was completely normal at the time. It was how these forests had always looked. The naturalist John Muir described watching a fire move through the same region in 1893, and what he saw was nothing like what we picture when we hear the word wildfire today. He watched flames race up brushy slopes and then, the moment they hit the deep forest, calm down almost completely, creeping along the ground, burning low through needles and scales, only flaring up occasionally around fallen branches or a lightning-struck tree. That was fire doing exactly what it had always done in these forests, moving through regularly, keeping the understory clear, and then dying back down on its own. The reason the forests stayed open was that fire was moving through them constantly. The General Sherman tree, the largest tree by volume on the planet, has likely lived through well over 100 burns in its 2,200-year life, with fires snaking along the forest floor roughly every 15 years or so. That's not a tree that survived despite fire. That's a tree that grew up inside a fire cycle and shaped itself around it. And then, in the late 1800s and into the early 1900s, that cycle stopped. The U.S. Forest Service and the National Park Service both adopted a policy of full fire suppression. The idea was straightforward. Fire destroys things, so stop the fire. Every lightning strike, every spark, every small ground fire got put out as quickly as possible. And for a while, it looked like it was working. The forests weren't burning. The trees were still standing. What could possibly be going wrong? The answer to that question is what I want to spend some time on, because this is where the story gets genuinely strange. And it starts with a researcher named Richard Hartsfeld, who in the 1950s was doing something that sounds almost boring, re-photographing old pictures of sequoia groves. Hartsfeld, a PhD student and part-time ranger, found a detailed vegetation map and collection of 1930s-era photographs of the Mariposa Grove in Yosemite, and began systematically re-photographing those same sites. What he found was that a lack of fire had drastically altered the ecology of the landscape. White fir trees had moved in and taken over, and sequoia reproduction had almost completely stopped. That last part is the thing that should stop you cold. Sequoia reproduction had almost completely stopped. These ancient trees were still standing, still enormous, still alive, but they weren't making the next generation. And the reason came down to something fundamental about how a sequoia actually works. Giant sequoia cones are serotinous, which means they don't open and release seeds unless subjected to heat. In a normal situation, a ground fire would spark the release of those seeds while simultaneously providing a bare mineral soil seedbed. The seeds don't do well, and generally don't survive, if they fall onto a layer of litter on the soil. They can't withstand the dryness of a Sierra summer without mineral soil to get down into and access the moisture stored there. So fire was doing two things at once that the sequoias needed. It was opening the cones, and it was clearing the ground. Take away the fire, and you take away both. The seeds fall onto a thick mat of old needles and debris, can't reach the soil, and die. Without periodic fires, the percentage of seeds that successfully germinate drops even further, and sometimes there's almost no regeneration at all. Researchers have described this as a massive failure of sequoia reproduction in groves protected from fire over the past century, driven by federal fire suppression and forest policies that emphasize short-term outcomes over long-term goals. Think about that for a moment. The groves looked fine from the outside. Tourists were walking through them, taking photographs, feeling that sense of ancient peace. But underneath the surface, the biological machinery that kept these forests going across millennia had quietly broken down. The old trees were there. The young trees weren't coming. And that's not even the whole problem. While the sequoias were failing to reproduce, something else was happening in the forest around them. Without regular fires, the buildup of fuel and the excessive growth of more fire-sensitive trees, like white fir, increased the risk of devastating crown fires, exactly the kind that have already destroyed significant portions of the sequoia population in recent decades. Here's the thing about white fir. It loves shade, it grows fast, and it has thin bark that burns easily. In a healthy fire-managed forest, it gets thinned out regularly and never builds up enough to carry a fire into the canopy. But with a century of suppression behind it, white fir had crowded into the sequoia groves in dense thickets. The same forest that Walker rode through on horseback in 1832 had, by the mid-20th century, become nearly impenetrable on foot. A photograph of the Mariposa Grove in 1890 shows wide-spaced sequoias with open ground between them. The exact same scene photographed in 1970 shows a dense wall of competing conifers. 80 years without fire had transformed the landscape completely. So now you have a situation where the sequoias aren't reproducing. The forest around them is packed with flammable material, and the policy in place is still to put out every fire immediately. And the question becomes, how long does it take before someone in charge figures this out and does something about it? The answer is longer than you'd hope, but faster than you might expect, given how entrenched the suppression policy was. One of the specific events that helped push things toward a new policy was the McGee Fire in 1955, a disastrous wildfire just west of Kings Canyon that burned 13,000 acres of brush and forest in a few hours and threatened the Grant Grove of giant sequoias. Soon after, a number of scientists began studying the role of fire, including prescribed burning, in the giant sequoia mixed conifer forest. Through the late 1950s and into the 1960s, researchers began publishing papers on what fire suppression was actually doing to western forests. Hartsvelt's work on the sequoia cones and seedbed was part of that wave. Tree ring researchers were building detailed fire histories from samples taken in multiple groves, and what they found was striking. Before Euro-American settlement, fire had moved through these groves on a regular cycle, with intervals ranging from about 6 to 35 years, depending on the location and the climate. Some of those fires covered less than an acre. Some covered hundreds. But they were constant and they were essential. In 1965, a crew of researchers from San Jose State began setting experimental fires in the Redwood Mountain Grove of Kings Canyon National Park. These were small, careful, closely watched burns on plots of just a few acres. but they were gathering real data on what happened when fire came back to these forests. And the results were clear enough that the National Park Service was ready to act. In 1968, the National Park Service changed its fire suppression policy to accept a more natural role for fire in park ecosystems. Lightning-caused fires were allowed to burn under specified conditions in Sequoia and Kings Canyon National Parks that year. Superintendent John McLaughlin of Sequoia and Kings Canyon approved the Park Service's first experimental natural fire program in the Middle Fork of the Kings River above 8,000 feet elevation. The 1968 Kennedy Ridge Fire was the first lightning-ignited fire allowed to burn in any national park in the country. That's worth pausing on. The first time the United States government deliberately allowed a fire to burn in a national park was 1968. Not 1900, not 1940. 1968. For nearly a century, the default response to any fire in any park was to put it out immediately, and the idea of doing anything else was genuinely controversial. Because of changes in scientific thinking that translated into new directions in management policy, the national parks became the testing ground for intentionally ignited fire, as well as for experiments in letting natural fires burn. Ecologically sound, this strategy was revolutionary, threatening, and even dangerous. Yet the NPS persisted in the face of challenges to its authority. 2 fires were allowed to burn during the first season, and by 1971, 52 fires had burned 617 acres. The program was expanding carefully, methodically, with researchers watching every burn and documenting what happened afterward. And what happened was exactly what the science had predicted. The sequoias responded. Seeds fell on bare, fire-cleared ground. Seedlings appeared. The next generation of giant sequoias, which had been missing for decades, started to come back. If you've found this useful so far, drop a comment below. I'm genuinely curious whether you knew any of this before watching. And if you want to keep going deeper on how ecosystems work and why the conventional wisdom around them is so often wrong, subscribing keeps this kind of content coming. Now, here's the part of this story that I think is the most important, and it's the piece that almost never gets talked about when people discuss forest fires in the news. Because by 1968, the National Park Service had the science. They had the data. They had the early results from the experimental burns. And they started doing the right thing. The great tragedy is that while from the late 1960s, on the NPS had begun a robust program recognizing the science of fire ecology and reintroducing fire to their lands, there was almost no adoption of prescribed burns beyond that agency. In the rest of the West, with the exception of a few indigenous peoples on their ancestral lands, most land management agencies still followed a policy of full suppression when fires started. In those 50 years since they should have known better, forests became more dense, brush thicker, the climate increasingly hot and dry. And that's how we arrived at the catastrophic fire conditions we experience today. The national parks were doing the right thing. The forests around them were not. And that gap between what the science said and what the policy allowed is the gap that modern wildfires are burning through. The 2015 Rough Fire is probably the clearest example of what that difference actually looks like on the ground. The hot and fast-moving Rough Fire burned outside the park, fueled not only by the accumulation of conifers and brush grown over decades of full fire suppression, but also through thousands of dead trees killed by bark beetles during a 5-year drought. It burned into the northern edge of Grant Grove and Kings Canyon National Park, which had been extensively treated by prescribed fire since the late 1960s. Fire specialist Anthony Caprio and his colleagues began surveying the grove even as it was still burning in places. They had maps of each historic prescribed fire, as well as before photos, to assess the relative effects of fire in the treated and untreated areas. The differences were striking. Direct fire-caused mortality of small trees was seen throughout the burn. But no direct fire-caused mortality was observed in medium or large trees in the area treated with prescribed fire, where fuel loads and tree density had been reduced, even though the fire occurred during an extreme drought. The prescribed fire hadn't stopped the wildfire from arriving. It had changed what the wildfire did when it got there. In the treated areas, the fire dropped back to the ground, moved slowly, and behaved the way John Muir described watching fire behave in 1893: calm, low, creeping. In the untreated areas outside the park, it was a different story entirely. And after the rough fire came through, researchers went back in and found something that brought the whole story full circle. Sequoia cones that had opened during the fire and shed their seeds, with the ground around them covered in sequoia seeds, which looked something like oatmeal flakes. The fire had done exactly what fire is supposed to do. It opened the cones, it cleared the ground, and the next generation of sequoias was already on its way. The park has fed the giant forest a steady diet of prescribed fire for over 60 years, after nearly a century during which fire was actively excluded from the grove. As recently as 2019, 500 acres within the giant forest near the General Sherman tree were treated with intentional burns. The resulting landscape, cathedral-like trees with almost no undergrowth, is what all sequoia groves would have looked like before Native Americans, who had conducted prescribed burns for thousands of years, were forcibly removed from their lands in the late 1800s. That's the part of this story that tends to get lost. The knowledge that fire was essential to these forests wasn't discovered in a university lab in the 1960s. Indigenous peoples had known it for thousands of years and had been actively managing these landscapes with fire long before any park service existed. The researchers in the 1960s weren't discovering something new. They were rediscovering something that had been practiced for millennia and then erased. So here's where we land. You walked into this video with a question about why rangers started burning old-growth forests. And the answer is this: they weren't destroying the forest. They were giving it back something it had always needed and had been denied for nearly a century. Giant sequoia seedling establishment typically increases substantially after fire and is sufficient to maintain sequoia populations if fires occur periodically. Research in multiple groves has shown that establishment on mineral soil without fire is not sufficient to maintain sequoia populations. Fire is needed for enough recruitment to keep these groves going. The trees that looked the most permanent, the most ancient, the most untouchable, they were quietly losing the future, while we were busy protecting them from the very thing they needed. And the rangers who started lighting fires in 1968 weren't being reckless. They were paying attention to what the science was saying, and they had the courage to act on it even when it looked completely counterintuitive to everyone watching. The groves that have been managed with prescribed fire for the past several decades are, right now, the healthiest and most resilient sequoia forests on the planet. The ones that haven't been touched are the ones in real danger. And the difference between those two outcomes is a policy decision made more than 50 years ago by a small group of researchers and one park superintendent who decided that the conventional wisdom was wrong. If this kind of deep dive into how ecosystems actually work is something you want more of, there's another video right here that goes into how the removal of wolves from Yellowstone changed the shape of rivers. And the science behind that one is just as surprising as this. Go watch it next.